Hi, I'm Sailesh, and this is learning with cats as a dog classifier. And we start with the first thing where you mount the Google Colab to the drive with this code, and the basic packages for running any ML, Matplotlib library, NumPy, PLI, TensorFlow, and all that. Um, you asked us to set up checkpoints so that for training purposes, if something fails, and also have a callback for the TensorBoard visualization. So data loading happens here, creating the directory for the training and validation, uh, followed by the train cats, train dogs validation directories. All of these codes has been done. I just ran these codes right now. I'm just showing you the codes so that there's nothing running during the explanation. This is just creating the data set. I'm using batch size as 10 for the initial model and the image shape as 150 because the training data only consists of 150 into 150. This is the data set, and this is the basic model creation. Um, Using the sequential model from the TensorFlow to create the model, and we compile it, model summary. Um, so I'm using 20 epochs to train the model. Um, So visualization of the validation training accuracy and validation training loss. So this is the table, and tensor board for the epochs accuracy is over here, and epoch loss is over here. The key observations from the basic model training is that the accuracy consistently improved and it reached almost to 94% with 20 epochs. The validation accuracy was lying around 69% and 73%. This we could infer that the model was struggling to generalize beyond this point. The loss, however, was up to the eighth epoch, it was 57%, and it got worse after the eighth epoch. So we could say that the model is struggling uh, by like overfitting beyond this point. Uh, So we saved the model, and so the deliveries for the for this assignment is to alter the parameters for model training. So the first parameter we're trying to alter is trying different epochs. So why we need to change epochs is why we could change it over here is since we know that from the previous training after epoch 8 the lowest validation loss is 57 and it only gets worse after that. So maybe if we reduce the epochs to a smaller number, we can have an early stopping point so the model doesn't overtrain, prevent overfitting because that's the biggest issue I think we're facing here. Uh, so I try epochs 10, so just doing the code, compiling it, and these are the TensorFlow data readings, epochs accuracy, and epochs loss. So the difference between 10 epochs and 20 epochs is for 10 epochs, the training loss consistently decreased. Validation actually fluctuated, increasing potential overfitting. So overfitting is still an issue. Uh, when we did 20, there was significant improvement training accuracy because there's more data to train on and there's more rounds where the model was trained on. But the validation performance did not improve at all. So 10 has a better validation performance. In the 20, there was more validation loss increased. In 10, we can see potentially getting lower. So we saved that model where we altered the epochs number, and the next one was to change the batch number. Uh, we I prefer to make it a smaller batch so that to enhance the validation accuracy, create more robust models by reducing overfitting. So in this way, the smaller batches help prevent the model from memorizing training data and improvising to generalizing to new data. So that's the validation set. More frequent updates from smaller batches lead to better weight adjustment and can improve convergence. So I've chosen 64 as the batch size and I've done my training. and these are the TensorFlow and TensorBird epoch accuracy, and this is the loss. We save the data. Batches of 60 showed improvements in stability, training accuracy, uh, but required more time for training because again it's 100 times faster, and only moderate validation performance. It wasn't that big, so we could just stick to batch size of 100, which allowed quicker training, but suffered from fluctuation, accuracy, and poor validation results. And the third deliverable was for changing the learning rate. So the optimizer which was used in the base model was an Adam optimizer which had a learning rate of 0.001. So we tried to make the learning rate even more lesser so that the model can learn more at a slower pace. So I made it to 0.0001. Smaller learning rate allows the model to converge more gradually, reducing discover overshooting optimal values. So this leads to like a stable updates, minimizing fluctuations in the validation loss. So normal code, and over here I just use the Adams optimizer in the TensorFlow class, and I changed it to the new learning rate of 0.0001, and we trained it, and these were the outputs on the TensorBird epoch accuracy and epoch loss. Uh, the 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 previous the basic the default value of the Adam optimizer was more effective um, for the training tasks, leading to better accuracy and low loss. So the 0001, the updated learning rate didn't really help much. We still got better results on the base model. We saved the model, and the last deliverable was to change the optimizer itself. So I went online on a major issue over here was overfitting. So I saw some optimizers which like perform better on overfitting the model data. So I came across Adam W, which is very similar to Adam. Adam W decouples weight decay from the optimization step, helping mitigate the overfitting issue more effectively. So I try to use that, and this is the code, weight decay 0.01. So this was something I found on the internet, which was being used. So I just followed the same thing and trained, and this is the TensorFlow, TensorBird readings, epoch accuracy, and epoch loss. Okay, it's not being loaded. Oh yeah, I did. Okay. The results indicate that the Atom Optimizer outperformed Atom W in the specific case, but in terms of training speed and final performance metrics, while Atom was generally favored for its ability to mitigate overfitting through decay, we could not see any significant benefits over here. So, out of all the deliverables, I wasn't able to find a parameter which would have made uh, the base model work better. Unfortunately, um, for our part two of this assignment as a which is a team group. So we since my base model is the best performing model out of all I have, so I converted that into a TF Lite model. So and I've saved it as uh, okay. So this is my base model, and it's been saved as model.tflite with this code, and all of my models are saved in my drive under these names. So this is the TF-Lite model, this is the base model, this is the one which is a different learning rate, different epochs, different batch size, and the different optimizer. And yeah, thank you.